Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International IGCSE Chemistry Paper 2CR for June 2022. Let us begin with the first question. Question 1. The diagram shows the subatomic particles in an atom of an element. This is the atom. We have electrons, which are, we see their protons as well as neutrons. So the question asks, give the name of each of the subatomic particles labeled P, Q, and R. We can see P that have no charge, those are going to be the neutrons. And then Q, if you look at Q, they are positively charged, those are going to be the protons, or that's a proton, while R has a negative charge, that is going to be an electron. Next they say, give the name of the part of the atom labeled S. The part labeled S is a nucleus. You can see that is where the protons as well as the neutrons are contained. Then they say, give the name of this element. To know the name of this element, you can see we have 5 electrons, or you could use protons, 1, 2, 3, 4, 5. That means it's going to be boron because it has 5 electrons in the elemental state. So this brings us to the end of question 1. Let's continue to question 2. Question 2. A potassium permanganate crystal is placed in a beaker of water. So we see this is the potassium permanganate crystal and that is the beaker of water. And they say, after several days, a colored solution forms. Give the names of the two processes that cause the colored solution to form. At first, this crystal is going to dissolve, and then diffusion will occur. So dissolution and then diffusion. In part B, the formula of potassium permanganate is as you see here. How many different types of atoms are in potassium manganate 7? So we see there is potassium, there is manganese, and oxygen. Remember they say different types, so there are only 3 different types, and the answer should be A. And next they say, calculate the relative formula mass, which is Mr of that. You can use your periodic table. Potassium is going to be 39, manganese is 55, then oxygen, each is 16, so 16 times 4 gives us 64. Add everything up, and you get 158. So the answer here should be 158 as well. In part C, potassium permanganate can be used as an oxidizing agent. State what is meant by the term oxidizing agent. An oxidizing agent is a substance that donates, in this case, oxygen or gains electrons from another. Or you could say an oxidizing agent causes something else to be oxidized, so it gets reduced. So this brings us to the end of question 2. Let's continue to question 3. Question 3. This question is about alkanes. Which of these is the molecular formula of an alkane? So alkanes have carbon N, hydrogen 2N plus 2. The answer here is going to be this. This is an alkane as well, but it's not in molecular formula state. It is in a structure formula state. So this is the only alkane with a molecular formula displayed here. Next they say, which of these has the same empirical formula and molecular formula? An empirical formula is the smallest whole number ratio of all the atoms within a specific substance or compound. However, for the empirical formula and molecular formula to be the same, it means we cannot find another whole number ratio except the molecular formula. So this is an alkane, and we can see we can have carbon, hydrogen 3, so that's out. The only possible answer is going to be this. You cannot divide this further to get a whole number ratio of these elements within that compound. In part B, in the presence of ultraviolet radiation, methane reacts with bromine to form bromomethane and hydrogen bromide. State the name of this type of reaction. So this type of reaction is going to be like this. We have methane, which is CH4. It reacts with bromine. If you look at the product side, Br binds onto this and the hydrogen goes away. So this is a substitution reaction. And in the next question, they say give the equation for this reaction. Of course, methane is going to react with bromine to give us bromomethane as well as hydrogen bromide. Moving on. In part C, 1 mole of an alkane burns completely in oxygen. The equation represents the reaction. So we have the alkane burning in oxygen to produce carbon dioxide and water. The numbers x, y, and z are used to balance the equation. So they say the complete combustion of 1 mole of alkane produces 220 grams of carbon dioxide and 108 grams of water. Calculate the values of y as well as z. So here we need to find the moles of carbon dioxide as well as the moles of water and then get the ratio. So the moles of carbon dioxide are going to be 220 divided by 44 and I get 5 moles. And the moles of water are going to be 108, which is the mass, divided by the molar mass, which is 18, and I get 6. So the ratio is going to be 5 to 6. If the ratio of carbon dioxide to water is 5 to 6, it means Z is going to be 6 and Y is going to be 5. So the hydrocarbon is carbon 5, hydrogen 12, because if this is a 6, it means the hydrogens this side are going to be 12, so the alkane should have 12 hydrogens as well. So down here they say determine the molecular formula of the alkane and the value of X. This is similar to what I've told you already. If this is going to be 6, it means we have 12 hydrogens in total, so the hydrogens should be 12. And if this is 5, it means we have 5 carbons in total, so carbon 5, hydrogen 12. And to balance this oxygen here, we have to find the total number of oxygen atoms the other side, which is going to be 6 plus 10, which is 16, meaning X is equal to 8. So as I showed here, X is 8, and that's my answer. Next they say, when an alkane burns in a limited supply of air, incomplete combustion occurs. Explain why incomplete combustion of an alkane could be harmful to humans. It is because it produces carbon monoxide, which is a poisonous gas. It also produces soot, which irritates the respiratory tract. So this brings us to the end of question 3. Let's continue to question 4. Question 4, the diagram represents the structure of copper metal. So we can see these are the metal cations, and those are the delocalized electrons. They say, explain 3 properties of copper that make it a suitable metal to use in electrical wiring. To be used in electrical wiring, it should be able to conduct electricity, and it should be able to be drawn in 2 wires. So here we're going to talk about in terms of having delocalized electrons and the idea that when a force is applied, the layers are going to slide past each other, but held by electrons so that there is no breaking apart. So the first one, it conducts electricity because it has delocalized electrons that can move when a potential difference is applied. We also see it is ductile and malleable because it contains cations that are arranged in layers, and when a force is applied, the layers slide with the electrons, meaning electrons are acting as glue, holding the cations in position wherever they slide. Another property is it has a high melting point because it is a giant metallic structure with strong electrostatic forces of attraction between cations and localized electrons, and this enables copper to withstand the high temperatures that can result sometimes when conduction of electricity occurs. Moving on. In part B, the diagram shows the electrolysis of copper 2 sulfate solution using graphite electrodes. So we can see this is the power supply, we have the positive electrode, we have the negative electrode, and the copper 2 sulfate solution. So they say copper forms at the negative electrode and oxygen forms at the positive electrode. They say give the formula of the copper ion and the formula of the sulfate ion in the copper sulfate. In copper sulfate, copper is 2 plus and sulfate is SO4 2 minus. The next they say state what will be seen at the positive electrode. Remember this is a solution, and in this solution we have 2 anions. We have OH minus as well as SO4 2 minus. So at the positive electrode, OH minus is going to arrive and then oxygen gas is going to be formed. However, it is going to be observed as effervescence. Remember they said what you see. You cannot say or you cannot write that you see oxygen because you cannot see it. So you just have to say effervescence, or you could say bubbling. Next they say give a test for oxygen. Use a glowing splint. If it relights, then that is proof that the gas is oxygen. Moving on. Here they say give an ionic half equation for the formation of oxygen at the positive electrode. You could write it like this. The hydroxide arrives. It's going to form oxygen plus water and then 4 electrons. So in the last part, suggest why the copper 2 sulfate solution contains some OH minus ions. The OH minus ions present are because water dissociates to produce OH minus. You would say water breaks apart to produce H plus as well as OH minus. So that is why there is some OH minus. So this brings us to the end of question 4. Let's continue to question 5. Question 5. This question is about alcohols, carboxylic acids, and esters. Ethanol can be manufactured by the fermentation of a solution of glucose. Write a word equation for this reaction. The word equation is glucose is converted to ethanol as well as carbon dioxide. Next they say, state the substance that needs to be added for the reaction to occur. In this fermentation reaction, we need to add yeast. And then they say, state two conditions needed for this reaction. First should be 30 degrees, and then it has to be under anaerobic conditions, because if oxygen is present, then there is further oxidation of the alcohol that could occur. In part B, in the presence of an acid catalyst, ethanoic acid is heated with butanol to form an ester. So they say which of these is the formula of the ester. Reacting ethanoic acid and butanol, this is going to go away, the OH is going to go away, and that hydrogen is going to go away. So this oxygen comes and attaches here to form what we see here. So this is going to be CH3, COO, 4 carbons and 9 hydrogens, and this is going to be my answer. Next they say, state how you would know that an ester has formed. An ester has a sweet smell. So when you smell something sweet, then that's proof that an ester has been formed. Next they say, give one use of an ester. It can be used for flavoring. It can be used for perfume, as well as in solvents. Moving on. In part C, aspirin is a compound used to reduce pain. Aspirin contains a carboxylic acid functional group and an ester functional group. State what is meant by the term functional group. A functional group is an atom or group of atoms that determine the chemical properties of a specific compound. Then next they say, this is the structure formula of aspirin, which we can see here. They say draw a circle around the carboxylic acid functional group. The carboxylic acid functional group has a carbon-oxygen double bond, and then on the other side it has oxygen and hydrogen, so this is that functional group. Next they say, aspirin has this percentage composition by mass, 60% carbon, 4.44% hydrogen, and 35.56% oxygen. So they say show by calculation that the empirical formula of aspirin is carbon 9, hydrogen 8, or 4. So I placed in a table carbon, hydrogen, oxygen. Then the number of moles is going to be the percentage composition by mass divided by the atomic mass of carbon. Here 4.44 divided by the atomic mass, which is 1, and 35.56 divided by the atomic mass, which is 16. So here I got a 5, 4.44, and 2.225. Then dividing through by the smallest number of moles, that divided by that is 1, that divided by that is 2, and that divided by that is 2.25. Now this is not a whole number, so I have to make sure I multiply it to create a whole number, and that will occur when I multiply by 4. So that times 4 gives me 9, that times 4 is 8, and that times 4 is 4. So it's going to be carbon 9, hydrogen 8, oxygen 4, and that should be my answer. So this brings us to the end of question 5. Let's continue to question 6. Question 6. A student uses this method to do a titration. Use a measuring cylinder to obtain 25 centimeters cubed of sodium hydroxide solution, and then transfer the solution to a conical flask. Add a few drops of universal indicator to the flask. Then fill a burette with dilute sulfuric acid and record the initial burette reading. Add the acid to the flask, swirling the flask continuously. Then add the acid slowly near the end point. Record the final burette reading at the end point. Then they say the student repeats the titration until at least 2 concordant results are obtained. State what is meant by concordant results. These are results that are within 0.2 of each other. You could say plus or minus 0.2. And in part B, explain 2 improvements to the student's method so that more accurate results are obtained. So if you go back here, the student used the measuring cylinder to measure 25. The error in that measurement is going to be big, so to decrease it, you could use a pipette. So I said, use a pipette instead of a measuring cylinder to measure sodium hydroxide. That pipette is more precise in its measurements. Then you could also use another indicator like methyl orange or phenolphthalein, which would give a sharp color change. Then use a white tile below the conical flask so that the color change at the end point can be clearly seen. Moving on. In part C, the student makes the improvements and repeats the titration. The sulfuric acid has a concentration of 0.600 mole per decimeter cubed, and the sodium hydroxide solution has a concentration of 1.5 mole per decimeter cubed. They say this is the equation for the reaction, which is given there. And then calculate the volume in centimeters cubed of sulfuric acid that the student needs to completely react with 25 centimeters cubed of sodium hydroxide solution. So we are given the concentration of sodium hydroxide as 1.5 and the volume is 25. Also, we know the concentration of the acid, which is 0.6, but we are looking for that volume. So since I have the two components for sodium hydroxide, I'm going to begin by calculating the number of moles of sodium hydroxide using the concentration times the volume. But I need to divide the volume by 1000 to convert it to decimeters cubed. So moles of sodium hydroxide are concentration times volume, which is the concentration 1.5 times the volume divided by 1000 to convert it to decimeters cubed, and that is my answer in mole. After knowing these moles, I can use the mole ratio, which is 2:1. So the moles of sulfuric acid are going to be a half those moles, which is what you see here, giving me 0.01875 mole. So finally, to find the volume of sulfuric acid is going to be easy. Volume is going to be number of moles divided by concentration, which is that divided by 0.6, and I got this as my volume in decimeters cubed. But remember, the question required us to write the answer in centimeters cubed. So by multiplying by 1000, I got 31.3 centimeters cubed as my answer. Moving on. In part D, the student plans to obtain pure dry crystals of hydrated sodium sulfate. They add the calculated volume of sulfuric acid to 25 centimeters cubed of the sodium hydroxide solution to form sodium sulfate solution. Describe what the student should do to obtain pure dry crystals of hydrated sodium sulfate from the solution. So all they need to do is heat the solution in an evaporating basin to create a saturated solution, and then as crystals form on the glass rod, stop heating and allow the saturated solution to cool down in order for crystals to fully form. Then dry the crystals using paper towels. And again, our aim here is to get hydrated, so I do not need to use an oven. I can just use paper towels to pat them dry in order to obtain the hydrated crystals. So this brings us to the end of question 6. Let's continue to question 7. Question 7. In the presence of an iron catalyst, nitrogen reacts with hydrogen to form ammonia. The reaction conditions used are temperature of 450 degrees Celsius and a pressure of 200 atmospheres. This is the equation for the reaction. We have nitrogen reacting with hydrogen to produce ammonia, and it's a reversible reaction. We also see that the delta H is negative 92 kilojoules per mole. This means that the delta H for the forward reaction only is negative 92 kilojoules per mole, so the backward reaction will be positive 92 kilojoules per mole. So they say, state what the symbol that represents. That means that the reaction is reversible. And next they say, give the reason for using a catalyst. A catalyst provides a new pathway with lower activation energy, so the reason as to why it's used is to ensure that the rate of reaction is fast. In part B, the reaction mixture is kept at a pressure of 200 atmospheres, but the temperature is increased to 550 degrees Celsius. Explain the effect of this change on the yield of ammonia at equilibrium. If you go back here, we see the forward reaction is exothermic, and increasing the temperature is going to shift the position of equilibrium to the left, meaning the yield of ammonia is going to decrease. So I say the forward reaction is exothermic, so increasing the temperature shifts the position of equilibrium to the reactant side, and the yield of ammonia decreases. Then they say the reaction mixture is kept at a temperature of 450 degrees Celsius, but the pressure is increased to 300 atmospheres. Explain the effect of this change on the yield of ammonia at equilibrium. So this is about increasing pressure. We go back here and see. The product side has 2 molecules and the reactant side has 4. So increasing pressure shifts the position of equilibrium to the side that has fewer molecules of gas. So that means more ammonia is going to be produced. So here said, increasing pressure will shift the position of equilibrium to the product side because it has fewer molecules of gas. So the yield of ammonia will increase. And here they say, draw an energy level diagram of the reaction between nitrogen and hydrogen and include the reactants, products, and the delta H in your diagram. So we know the forward reaction is exothermic, so the products are going to be lower in energy than the reactants. So nitrogen plus hydrogen gives us ammonia, which is lower. So delta H is going to be negative, and therefore the arrow is going to be pointing down. If you actually want, you can even write the real value, negative 92 kilojoules per mole, like this. Moving on. In part D, at the start of the reaction, 48 decimeters cubed of nitrogen is added to 120 decimeters cubed of hydrogen at room temperature and pressure. They say the molar gas volume is 24 decimeters cubed. Show by calculation that nitrogen is in excess. So here, we know number of moles of nitrogen is going to be the volume of gas, which is this one here, divided by the molar volume. So the number of moles are 2. And also the number of moles of hydrogen are going to be that divided by 24, which gave me 5 mole. So from the reaction equation, the ratio is 1:3. And that means 5 moles of hydrogen require 5 divided by 3 moles, which is 1.67 moles of nitrogen. But we can see the available nitrogen is 2 mole, so we can see nitrogen is going to be in excess. So I said, but nitrogen is 2 mole, which is more than 1.67 mole, so nitrogen is in excess. The next part says the yield of ammonia at equilibrium is 20%. Calculate the volume in decimeters cubed of ammonia formed from 120 decimeters cubed of hydrogen. Since nitrogen is in excess, we're going to use the moles of hydrogen. So moles in 120 decimeters cubed of hydrogen are going to be 5 moles, and meaning the theoretical moles of ammonia are going to be, when you go back to the equation, you can see the moles of ammonia are going to be 2 divided by 3 times the moles of hydrogen. So 2 divided by 3 times 5, which gives us 10/3 mole, or you could say 3.33 mole. Now to find the volume of gas, it's going to be number of moles times molar gas volume, which is the moles we have here, 10/3 times 24. I took this instead of that so that I can use exact values. So 10 divided by 3 times 24 gives us 80 decimeters cubed. But with 20% yield, it's going to be 20 divided by 100 times that, giving me 16 decimeters cubed. And that should be my answer. So this brings us to the end of question 7, as well as to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.